Okay, in this video we're going to just answer some questions which involve using the properties of dot product that we looked at earlier. So this question says A and B are unit vectors, so remember that means they have magnitude 1. And then 2A minus B and A plus 3B are perpendicular vectors, so they're perpendicular to each other. We want to get the value of A dot B. So what we need to do, or one way to do this question, is to use the fact that these two vectors are perpendicular. Anytime you see the fact that two vectors are perpendicular, that should tell you that their dot product is 0. So that doesn't mean the dot product of A and B is not 0. The dot product of 2A minus B and A plus 3B is 0. So I have this vector dot this vector. So now what we can do is sort of expand it, and because of all those properties, this will expand much like a regular multiplication of binomials would. Remember that dot product is distributive, meaning we can distribute, meaning you can take this and do the dot product of this, and the dot product of the second one, and okay, just like you would with regular binomials, it works for dot product because dot product is distributive. So this would be 2A dot A plus, and then I have 2A dot 3B, but one of the properties about scalar multiplication is that you can just multiply um, the constants. So that'd be 2 times 3, which is 6, times A dot B, and then distribute the B. So this would be negative B dot A, and then this B, you would have negative 3B dot B, and that's equal to 0. So this is 2A dot A. Remember that A dot A is equal to the magnitude of A squared plus 6A dot B. Here I have B dot A. Well, I can switch the order. Remember, dot product is a commutative operation. So that's A dot B minus 3, and then B dot B. Remember, you can write magnitude of B all squared. All right, now we can simplify a little bit. Remember that A and B are unit vectors, meaning the magnitude of A is 1. I have 6A dot B minus A dot B. So those are like terms. So that'd be 6 minus 1 is 5A dot B. And then minus 3 magnitude of B squared, that would be 1 squared. Okay, so that's 2 plus 5A dot B minus 3 equals 0. Remember that we're looking for A dot B. Well, that's the only unknown in this equation, so I'll just solve for A dot B. So 5A dot B, rearrange. So this would be 3 minus 2 on the side, so that would be 1. So A dot B is equal to, if I divide by 5, 1 over 5. So that's the value of A dot B in this example. Okay, second example. We've got two vectors, A and B, which are unit vectors, so it's just like the other example. But this time we know the angle between them is 60 degrees, and we want to calculate this quantity. So you are definitely going to have to expand this in the way we did with the previous question, but before we do that, I'm going to try to figure out what A dot B is. So I know that A dot B is equal to the magnitude of A times the magnitude of B times the cosine of theta, which in this case is 60. Magnitude of A is 1. Magnitude of B is 1. And then the cosine of 60 is 1/2. So A dot B is equal to 1/2. That will be useful when we do this. So now I'm just going to go and look at this. So 7a minus b dot 3a plus b. So I want to calculate this value. So I'm going to distribute much in the way I did in the previous example. So 7a dot 3a, that's going to be 21a dot a plus 7a dot b. So I did this one. Minus 3 b dot a. So that's this one here. And then that one gives me negative b dot b. Okay, so just simplify this as much as you can. So 21a dot a, remember a dot a is the magnitude of a squared plus 7a dot b minus, and then 3b dot a I can write 3a dot b because vector dot product is commutative, and then b dot b is the magnitude of b squared. So now I have 21 magnitude of a squared, remember that's 1 squared. 7a dot b minus 3a dot b, those are like terms. That'd be 4a dot b minus magnitude of b squared, that's 1 squared because it's a unit vector. So you have 21 times 1, which is 21, plus 4 times a dot b, but remember that's why we had done this earlier. A dot b is a half minus 1. 1 squared is 1. So that gives me 21 minus 1 would be 20, plus 4 times a half, that would be 2. So it gives me a total of 22. So the dot product of these two vectors works out to just 22.